In this lecture, I'm going to explain how an OSPF designated router is elected and the purpose of a DR and how it can be changed. So in this topology, I've got an Ethernet network, and there's actually 4 routers, and they're all connected through a switch. So this is actually Ethernet. Ethernet is a broadcast network. Anytime you have a group of routers connected through a switch in an Ethernet topology, there is a designated router elected and a backup designated router. When you have 2 routers connected on a point-to-point link, they don't elect any DR. It's a point-to-point link, so advertisements are sent between the 2 routers directly. When you have this sort of broadcast network, what happens is OSPF elects a designated router to advertise routes to all other routers that are connected within that LAN segment. So in this example, router 4 is currently elected as the designated router. The reason is because it has the highest router ID, 255.4. All priorities on an OSPF router are a default of 1. So with that, the DR is elected based on the router ID. So in this example, router 3, router 1, and router 2 will send all their routing updates to router 4 instead of to each other. And router 4 would then send those routing updates to all 3 routers. So basically it's kind of a hub and spoke. The routers are not meshed. The routers each only communicate directly with the designated router, and the DR then communicates directly with all 3 routers. So in this example, router 4 is the DR, the elected DR, and what I'm going to do in the lab is change it so that router 2 becomes the designated router. And how I do that is I change the OSPF priority setting on router 2 so that it then is elected as the DR. So if I want to go to router 1, for example, and here are these messages, ADJ, that means adjacency has been established with neighbors. So I know that OSPF is running okay, and full means that it's full adjacency with the neighbors. So what I'll do is I'm just going to go and I'll show you how to verify this. Show IP OSPF neighbor. And when I do this command on router 1, it tells me what the DR is. So the DR is 192.168.255.4, and I know from the topology that that's router 4. So that tells me that's the DR. The full means it's full adjacent. It just means it's adjacent with the OSPF. It has a OSPF adjacency, so it will exchange routes. The DR means that's the designated router for router 1. So router 1 will forward routing updates to router 4. And the other one, this BDR, is the backup designated router, and that's .3, because 3 is the second highest router ID. So what I'm going to do now is go to router 2, command line interface, and I'm going to change the designated router. So to do that, I have to do it on an interface. So the interface on router 2 that connects to this multi-access Ethernet network is, I'm just going to enable ports. So in this example it's 00, so I have to change the OSPF priority on that interface. So what I'm going to do is go to interface FA00, and I'll type IP OSPF priority. I'm going to change it from 1 to 100. And by doing that, that will now be elected as the designated router instead of router 4. That's really all there is to it. But it is done on the interface that connects to the area. In this case, this is area 0. As you note, they're all connected through area 0. So to do this, what I have to do is I'm going to have to restart, because if I don't restart the devices, you won't notice it. So I'm just going to recycle the devices. I could change the timers in that to update quicker, but it's easier to do it like this to show you that Usually when something's designated as a designated router, typically you'd have to turn off the interface or something to then trigger the reelection. In this case, I'm just going to do this. What I'll do is I'll go to router 1, and at this point I'm going to wait for adjacency to occur between the OSPF routers. I'll just go fast forward. Wait till that happens. There it is there. So now it's becoming adjacent with all its neighbors. Actually, no, just the router 4. Oh, actually it used to be router 4, but it's actually becoming adjacent with, in this case, yeah, it's becoming adjacent with its neighbors. So, but it's not, it's only going to exchange routes with router 2. So in this case, what I'll do is, so it's got adjacencies with neighbors, but they're not all the same though. So in this example, router 1, I'm on router 1, so it's got adjacency with all three, dot 2, 3, and 4. That's router 2, router 3, and router 4 now. And so the only difference now is the DR is router 2. That's 192.168.255.2 because it's got 100 priority. So it's higher than the other neighbors. If you want to know what the priority is of router 1, you'd go show IP OSPF interface, and then you have to use the interface 00 because that's what it's using to area 0. In this case, the priority is 1, and it's DR other. So it's not a BDR and it's not a DR, it's a DR other. So that just confirms that. And if I go over to router 2, I can do the same command. This is now the elected DR. So I'll show the neighbor command, show the adjacencies are there. And 4 is the BDR. And 3 and 1, it has adjacencies with all of them as it should. And it's the DR, so it doesn't show as being the, it doesn't show itself in the list, it wouldn't do that. Show IP OSPF interface FA00. At this point there's a priority 100 and state DR. So router 2 is showing, it knows that it's the DR. And now it's the current DR, and that includes OSPF DR.